Hi, Computer and Information Technology students. I just wanted to provide a quick little walkthrough of the math support modules that are in the Computer and Information Technology Field of Interest Canvas course. So you can see here I'm logged into that Canvas course, and I'm going to scroll down. I'm in the Modules section, and I'm going to scroll on down into Resources and Academic Support. And here we have the Math module. And I want to briefly show you what topics are covered in here. We have exponents, base conversions, a symbolic logic overview, word problems to algorithms, and algorithms to process steps. So let's quickly go through some of these to give you an idea of what kind of information is here. Exponents go through the basics of exponentiation. Okay, not only how to use them, but what they mean. There's some videos that you can go through for more in-depth information. We cover some exponent rules, namely how would you manipulate exponents if you were doing arithmetic operations on them. And there's a short piece on scientific notation and how it relates to place value. All of these are topics related to exponents. And then each of these sub-modules has a uses in computing section near the bottom, which is past all the math explanation, and it connects the topic to an interesting application in computing. Okay, here for exponentiation, of course, we're going to connect it to programming and how exponentiation is represented in some different programming languages. Okay, and also how, again, exponentiation relates to other bases. Each one of these sections, information sections, has a quiz associated with it, and this will be a live link that takes you directly to the quiz. But again, you can get to the quiz from the modules section. And then there's a further exploration piece at the very end, which has links where you can read about some of these topics in more depth if they interest you. So I'm going to go back out to the modules and give you a look at the Exponents Quiz. You can see these two have the same name, except the quiz is called Practice. These are set up as practice quizzes, but your instructor may decide to award you points for taking them. And you can see these relate to the topics that were covered in the exponent section. Here's some information on exponent rules. Okay. And pretty much every one of these subtopics is set up the same way. Base conversions deals with binary, octal, and hexadecimal arithmetic, which are important in representing data that's stored in a computer. And there's also information not only on converting from one base to another, but also doing arithmetic in the different bases. And again, just like the other modules, this has its own quiz. The logic topic is a very brief introduction to symbolic logic, okay, and basic operations, conjunction, disjunction, not, conditional implications. This material is a part of math that's really useful if you were going to do something like design a logic circuit in a computer. So we cover truth tables and equivalence and a whole lot of other laws of logic. Okay? And again, we talk about designing circuits as an application to computing. The last two sections, word problems to algorithm and algorithms to process steps, are designed to be used together. The first part, word problems to algorithms, gives you steps for starting with a description of a problem that someone would give you, say in a business context, and how to build an algorithm that you would use in preparation for writing software. Okay, so it goes through the actual steps, okay, as far as translating certain words to operations in an algorithm. And the uses in computing section actually starts with an example. It sets up a hypothetical problem So you're meeting with a chief financial officer of a company, and she wants you to answer a question for her, and she wants you to write some software to do it. So again, we walk through this particular problem using the same steps as above, and we come up with pseudocode, which is code that tells you what the steps and the variables are in your algorithm, but it's not quite to the level of code. And again, if we back out and look at the last section, algorithms to process steps, that's where we take our algorithm, which can be pseudocode or it could be a flowchart, and it basically shows you what you have to do to turn that into actual software, to actually write code. And we finish with that example from the previous section where we take our pseudocode that we wrote in the last section and we build a Python program from it. So again, the last two sections in the math modules over here are meant to be used, this one first and then the second one. And again, you can practice with the quizzes, but they kind of walk you through a very, very simple but real-world example. So I hope you find these math modules useful in your computing courses, and I hope you take the time to try the quizzes and maybe even look at some of the further exploration that are included.